All right, so now we're moving on to the next section, and we're going to go back to our book. So it's chapter 6, and we're moving on to section D, and it is similarity. Right. So before our last test, we learned about congruent triangles. So we knew that congruent triangles were the exact same size and the exact same shape. They were replicas of each other. They were identical. If we put them on top of each other, they would completely line up and match up perfectly. But we also knew that that meant all of our corresponding sides and angles were congruent, that they were all the exact same size, right? But now with similarity, that's going to be a little different. So in similarity, we can have two triangles that are the exact same shape, but they do not have to be the exact same size, right? One is an enlargement of the other. And we're going to talk about this in detail. So if this beginning part is confusing you a little bit, we will discuss this a lot more throughout this video. But the difference between is just like our congruent triangles, all of our corresponding angles have to be congruent. So nothing changes with that part of it. So just like congruent triangles, all of our corresponding angles are the same. But what is different is, let's just name this triangle A and triangle B for now. What's different, 2, 4, and let's say 5, and let's say 4, 8, and 10. What's different is our sides do not have to be the same because they're not the same size. They are the same shape, and that's why our angles are still the same, but they are not the same size. One of them could be an enlargement of the other. And what you have to do is you have to see, are they proportional? Right? Are they proportional? And there's going to be a few shortcuts that we will learn as well, but proportional, that means that they will create the same ratio. So if I'm going from one triangle to the other, so triangle A to triangle B, all of my ratios then must be written in that form. This side 2 is between 1 arc mark and 3, so it corresponds with this side of my triangle. So I do 2 over 4. This side 5 corresponds with the side 10, so I'd have to write that in the same order, triangle A to triangle B. And then the last one, this side 4 corresponds with this side 8. So it would then be 4 over 8. And then all of these reduce to 1/2. So all of these have the exact same ratio, right? They all reduce to the same ratio, 1/2, so that means that they are all proportional, right? And we are going to talk about how we can denote that, and we're going to talk about this a little bit more. But just know that it's similar to congruent triangles because all of our angles are the same, but it's different because our sides are not, right? They do not need to be the same size, but they do need to be proportional. All right, let's go ahead and we're going to talk about a few things more, and then we'll go through a couple examples. All right, so as I was saying, if two figures are similar, then their corresponding sides, so just like congruent triangles, that they need to be corresponding, they're in proportion. Meaning, if we put them in a fraction, so let's just say x over y, they will reduce to the exact same ratio. They will all have the same ratio. Right? So this means that the lengths will increase or decrease by the same ratio, and we denote that ratio by the letter K, and it's called our enlargement factor. All right, it's important that you know this letter K because what we do in our next section, we are going to say what K is equal to, and we're going to use that to solve some questions. So it's important that you know that K is referring to the ratio of our triangles that are similar. All right, so now we will learn some shortcuts just momentarily. But in order to show, or if we know that two triangles are similar, then the figures are equal angular. And that means that all of our angles are the same. So all of our angles are exactly the same. Right? So that means all of our angles are the same. And then our corresponding sides are in proportion. So that means they all have the same ratio. So we did that already with this one before. So we showed that all of our angles were the same, and then we showed that all of our sides are proportional. So, and if I tell you two triangles are similar, then we know that these two things 100% happen to occur, that they are equal angular and all their sides are in proportion. Just like with congruent triangles, where we learn side, 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 and side angle sides, etc., we're going to talk about just a couple shortcuts. We're not going to go through all the ones that you have for these, but we're just going to talk about 2 of them, and you can use those to help you determine if two figures are similar quicker than having to show all of this, just like we had to with congruent triangles. All right, so let's talk about that, and then we'll move on to the examples. All right, so to test if triangles are similar, rather than showing that all of the angles are the same and that all are the sides of proportion, we can just show if two pairs or just a pair of angles are congruent. Two pairs of angles are equal in size, and that guarantees the triangle is going to be similar. Right? So if I give you this triangle, and then I give you this triangle here, and I tell you that this angle is congruent to this angle, and I tell you that this one is congruent here. Although you're supposed to show that all of our sides are proportional and all of our angles are equal, this is enough information. Once we have two angles, we can stop and say, yes, that they are similar. And the reason is, in a video before, we learned that if we have two congruent angles, we know the third one, in a triangle, we know the third one has to be congruent by our third angles theorem. So we don't need to show that necessarily. We know, guarantee that those third angles are congruent. So once we know all of our angles are congruent, we are guaranteed that these triangles are going to be proportional, right? So if you can just show that two pairs of angles are congruent, then that is enough information for you to say that this is similar, that yes, they are. All right, let's talk about this second bullet point. All right, the second shortcut that you can do is here, you don't know anything about our angles. So if you can just show that their sides, their corresponding sides are proportional, then that's enough information for you to stop and say, yes, they're similar. So what we would need to do then is we would need to create ratios for all of our corresponding sides. So I'm just going to go from triangle A to triangle B. All right, I know that this side would have to correspond with this side if they're similar, because 3 is the shortest side out of this triangle and 9 is the shortest side out of this triangle. So if they're going to be similar, these two would have to correspond. So I can then create that fraction of 3 over 9, and that reduces to 1/3. Right? Then I can move on to the next one. I would know that 8 would have to correspond with 24 if they're similar, because 8's the middle side and 24 is the middle side. So if they're going to be similar, the two middle sides would be corresponding. So then I can put these into a fraction, 8 over 24, and that also reduces to 1/3. And then we would have to test the last one. So these two would have to be corresponding, and 10 over 30 reduces to 1/3. So check, they all are proportional. So yes, these are similar, right? And it doesn't matter if you did A over B or if you did B over A, you would still get the exact same ratios. They would all just be reverse or reciprocals. So they would all be 3 over 1. All right, so these are the two shortcuts that you can do. You can just stop and say, well, if I have two pairs of angles that are equal in size, I can stop and say, halas, finish. We know that they are going to be similar. Or if I show that all their sides are proportional, I don't have to show anything about their angles. All right, now we're just going to go ahead and move on to 2 examples. Or I guess technically it's going to be 3 examples because these are 2 and 1. All right, so here it says, show that the following figures possess similar triangles. So what I'm going to do first is I'm going to just redraw these 2 parallel lines on my triangles. I'm just going to extend them a little bit. All right, so here are my 2 parallel lines. And I'm going to draw them down here. So these 2 black lines are the exact same as these 2 bottom of our triangle. Then I'm going to draw this blue line here, and that's our transversal because it's intersecting them. And that's going to represent this part here. Well, I know that these 2 angles have to be equal to each other because they're corresponding. So that means this angle has to be equal to this angle because they're corresponding since the 2 sides are parallel. All right, I'm going to erase this blue line now. And now let's go ahead and label this other side as a green line. Same thing. Since these 2 sides or lines are parallel, that means these 2 angles are corresponding, so they have to be equal. So I can then go ahead and draw that in. Right now, I can stop and say that there's enough information that these 2 triangles are similar because 2 pairs of angles are congruent. I can also say that angle A is in both of our triangles. It's in this smaller triangle, and it's in the bigger triangle. So since angle A is in both of those triangles, that means angle A is, of course, going to be congruent to itself. So that shows that all 3 angles are congruent. All right, so yes, these are going to be similar. And I know it doesn't ask for it, but we're going to write what's called a similarity statement. Right? Just like we were able to write a congruency statement, we can write similarity statements to show that 2 triangles are similar. And it's exactly the same thing. The corresponding sides have to be written the same. So the first triangle doesn't matter how you write it, so I will say triangle ABC. But the similar figure, or the similar symbol is here. So triangle ABC is similar, and then I went ABC, so I need to go triangle ADE. Right, triangle ADE. Right, now, we may ask you to not just only write the arc marks, but you might have to show that angle A is congruent to angle A. You might have to show that angle ABC is congruent to angle ADE, and you might also have to show the angle ACB is congruent to angle AED. All right, it all depends on what the question's asking, but you might need to show your work here and explain. So we would then say that these are corresponding angles, and here we can say reflexive property. All right, I know we're not doing proofs right now like we just were, but you could be asked to do something like that. All right, now let's move on to the next question. Same thing, I'm going to highlight my two parallel lines that they gave me here, my sides of my triangles in black. So I'm going to draw them off to the side. I'm going to then draw this side, AE, in green, and that's going to be the same exact side here. So I know that this angle is congruent to this angle because they are alternate interiors. So that means that this angle here is congruent to this angle here. 100% guaranteed because they're alternate interior. All right, so I can then erase that. And then same thing, I have my two parallel sides. And now I'm going to go ahead and draw my other side of my triangle in red, and we can then duplicate that down here. So there's the two parallel sides, and here's my red side. Well, I know that since these two black lines are parallel, that this angle is congruent to this angle by alternate interior angles. So I know that this angle is congruent to this angle. So then I can go ahead and say that, well, now I know that these two triangles are 100% similar because I was able to show that two of the angles are congruent. And you can also show that these angles are congruent because they are vertical. So I know 100% that these are similar. And if I ask you to write a similarity statement, it would be triangle ACB is similar. So I did ACB. So it will then be ECD. So triangle ECD. Right? It may not ask, we may not ask that, but if we do, this is how you would write it. All right, now let's move on to the last example, which is going to be solving for a missing side, and then that'll be it for this video. All right, so in the diagram given, establish that a pair of triangles is similar and then find x. All right, so now I know that these two angles are congruent because they're corresponding. Since these two lines are parallel, I know that they're corresponding, they're in the same position. Right, and I know that these two angles are congruent because once again, they're also corresponding. It's similar to the one of the angles we just did. So now we can go ahead and say that this triangle is 100% similar to this triangle. Right, so I'm going to draw these two triangles off to the side. The reason why I had you do the similarity statement before, because sometimes it could be very helpful to write a similarity statement, and it will help you identify the sides that are proportional. So you can help create your ratios that way a little bit easier. Since these are not named, I'm just going to draw them off in their two different colors. I'm going to fill in the sides that I know. So this blue I have is 5, and this is x. And the red one, that's both of these combined, so it's 8, and this is 6. So since I know that these two sides correspond to each other, and since I know that they're similar by angle, I can then create a ratio. So that's going to be 5 over 8. I know that this ratio would be 5 over 8. So then I will create a ratio for my angle, for my side dealing with x. And that will be the ratio of x over 6. And since we know that all of our ratios will always be equal, all of our ratios will always be the same, we can then create a proportion and set these equal to each other. And when we have two fractions that are equal to each other, something we did before earlier in the year, we can do cross multiply. So we would then get 8 times x, which is 8x, is equal to 5 times 6, which is 30. And we divide each side by 30. And x is then equal to 30 over 8 will then reduce to 3.75. So 3.75 centimeters. If we don't ask you to round it, you can leave it as a fraction and it will reduce to 15 over 4. All right, so that is it for its video. It's important that you can identify the two figures are similar because once you can, if you have a missing side, you can create your ratios of the sides that you do have and then make a proportion. And from there, you can cross multiply and solve. Right, that is it for this video.